The screen fades in from black. A single server room appears. Cold, silent, blue LED lights blinking like distant stars. Suddenly, everything goes dark. A single line appears on screen. One misconfigured setting, and the entire world can see your data. Cut to a dramatic montage. A developer pushing code at 2 a.m., a cloud dashboard with hundreds of toggles, a hacker scanning the internet for exposed buckets, a company boardroom in panic. A headline, massive data breach caused by a simple cloud misconfiguration. Narrator, calm but intense. In the cloud, security is not a product, it's a partnership. And the moment one side fails, everything fails. The Knowitrix logo pulses in, music rises. Cloud adoption is exploding. Every company, from startups to governments, is moving to AWS, Azure, and Google Cloud. But with this shift comes a dangerous misunderstanding. Most people think the cloud provider protects everything. They don't. And this misunderstanding has caused some of the biggest breaches. In this module, we're going to break down the shared responsibility model with absolute clarity, not with boring definitions, but with real-world cases, analogies, visual storytelling, and practical steps you can apply immediately. By the end of this video, you'll understand what AWS, Azure, and GCP actually secure, what you must secure, why misconfigurations are the #1 cause of cloud breaches, how to avoid the mistakes that cost companies millions. The tools, frameworks, and best practices used by top cloud security teams, and how to think like a cloud security architect. This is not theory, this is survival. Section 1. The cloud is not a building, it's a city. To understand shared responsibility, imagine this. You move into a massive, futuristic city. The city is built by AWS, Azure, or GCP. They provide roads, electricity, water, security cameras, fire alarms, building foundations, emergency services. But inside your apartment, that's on you. You decide who gets a key, what valuables you keep, whether you lock the door, whether you leave the stove on, whether you install a safe, whether you open the window for strangers. If you leave your door open and someone steals your laptop, you can't blame the city. This is the shared responsibility model. Section 2. The official definition explains simply. Cloud security is divided into 2 parts. 1. Security of the cloud, provider's responsibility. This includes physical data centers, hardware, networking infrastructure, hypervisors, storage systems, global availability zones, power, cooling, disaster recovery, core cloud services uptime. AWS, Azure, and GCP guarantee these are secure. Security in the cloud, customer's responsibility. This includes identity and access management, IAM, data encryption, network configuration, security groups and firewalls, key management, application security, OS patching for IaaS, container security, API security, logging and monitoring, misconfiguration prevention. This is your job. If you misconfigure an S3 bucket, Azure Blob, or GCP storage bucket, that's on you. If you give admin access to everyone, that's on you. If you forget to enable encryption, that's on you. The cloud provider gives you the tools. You must use them correctly. Section 3. The 3 cloud models and how responsibility changes. To make this even clearer, let's break down the 3 cloud service models, IaaS, PaaS, and SaaS. Each model shifts which responsibilities are yours and which belong to the provider. IaaS, Infrastructure as a Service, EC2, Azure VM, GCP Compute Engine. You manage OS patches, security updates, IAM, network rules, application security, data protection, encryption, logging. The provider manages hardware, virtualization, storage, networking, data center security. This is the most responsibility you'll ever have in the cloud. 2. PaaS, Platform as a Service, AWS Lambda, Azure App Service, GCP Cloud Run. You manage code, data, access control, secrets, API security. The provider manages OS, runtime, scaling, patching, infrastructure. Responsibility is reduced but not eliminated. 3. SaaS, Software as a Service, Office 365, Gmail, Salesforce. You manage user access, data, device security, MFA, compliance settings. The provider manages almost everything else. Section 4. The most important rule in cloud security. The more control you have, the more responsibility you have. The less control you have, the less responsibility you have. This is why IaaS equals highest responsibility, PaaS equals medium responsibility, SaaS equals lowest responsibility. But here's the twist. No matter the model, you always own your data, and data is what attackers want. Section 5, Real-World Case Study, the Capital One Breach. This is one of the most famous cloud breaches ever. What happened? A misconfigured AWS WAF, Web Application Firewall, allowed an attacker to access metadata credentials. Those credentials were used to access S3 buckets. Who is at fault? Not AWS. The misconfiguration was on the customer side. Lesson: even the most advanced cloud services cannot protect you from your own misconfigurations. This is why shared responsibility matters. Section 6. The most dangerous myth in cloud security. Many companies believe we move to the cloud, so we're automatically secure. This is false. Cloud providers secure the infrastructure, but they do not. Configure your IAM, protect your APIs, encrypt your data by default, detect your misconfigurations, write your firewall rules. Cloud providers do not. Patch your applications, manage your secrets, monitor your logs, prevent insider threats, stop you from making mistakes.
The cloud gives you power, but power without understanding is dangerous. Part 2. AWS versus Azure versus GCP. How shared responsibility actually differs in the real world. The screen transitions from the dramatic opening of Part 1 into a smooth, futuristic animation of 3 massive skyscrapers rising from the ground, each one glowing. Each one glowing with a different color. Orange for AWS, blue for Azure, multicolor for Google Cloud. Narrator: every cloud provider follows the shared responsibility model, but each one implements it differently, and these differences matter more than most people realize. The camera zooms into the first skyscraper. Section 7. AWS Shared Responsibility, the most mature, the most granular. AWS was the first major cloud provider, and naturally, it has the most detailed and well-documented shared responsibility model. But with great power comes great complexity. To understand AWS's approach, imagine a massive toolbox. AWS gives you every tool you could ever need: hammers, drills, saws, laser cutters, robotic arms. But AWS does not tell you which tool to use, when to use it, or how to avoid cutting your own hand off. This is why AWS misconfigurations are so common. AWS responsibilities: security of the cloud. AWS secures global infrastructure, regions, AZs, edge locations, physical data centers, hardware, networking, storage, hypervisors, managed services infrastructure. Availability and durability of services like S3, DynamoDB, Lambda. AWS ensures the building is safe. Customer responsibilities: security in the cloud. You secure IAM users, roles, policies, S3 bucket permissions, security groups, and NACLs, encryption keys, unless using AWS managed keys, EC2 OS patching, container images, secrets, API gateway security, VPC design, logging and monitoring, data classification and protection. AWS gives you the locks. You decide whether to lock the door. Section 8. Azure Shared Responsibility, the enterprise-friendly approach. Azure's model is similar to AWS, but with a twist. Azure integrates deeply with enterprise identity systems. This means Azure assumes you already have Active Directory, group policies, enterprise security teams, compliance requirements, hybrid infrastructure. Azure is like a city built for large corporations. It expects you to bring your own security culture. Azure Responsibilities, Security of the Cloud. Azure secures physical hosts, data centers, network fabric, hypervisors, managed service infrastructure, platform patching, global availability. Customer Responsibilities, Security in the Cloud. You secure Azure AD identities, conditional access, RBAC, Key Vault secrets, NSGs, ASGs, VM/OS patching, storage account access, API security, Defender for cloud configuration, logging and CM integration. Azure gives you a well-structured office building, but you decide who gets a badge and which rooms they can enter. Google Cloud takes a different approach. GCP assumes humans make mistakes, so let's automate everything humans usually mess up. This is why GCP has automatic encryption at rest, enabled by default, automatic network segmentation, automatic IAM inheritance, and automatic key rotation, if configured. GCP also provides automatic service account creation and automatic firewall defaults that deny everything. GCP is like a smart home that locks itself, turns off the stove, and shuts the windows automatically. GCP Responsibilities, Security of the Cloud. GCP secures global infrastructure, hardware, networking, hypervisors, managed service infrastructure, encryption at rest, default, and global backbone security. Customer Responsibilities, Security in the Cloud. You secure IAM roles and permissions, service accounts, VPC firewall rules, data classification, API security, and more. GCP reduces your risk by reducing your choices, but you still control the data, and attackers still want it. Let's break down the differences in a way that's easy to visualize. 1. Identity Management AWS IAM. Powerful but complex. You can create extremely granular permissions, but also extremely dangerous ones. Azure AD, enterprise-centric, deep integration with Microsoft 365, on-prem AD, and hybrid identity. GCP IAM, role-based and inheritance-driven. Simple, clean, but easy to overgrant if you're not careful. 2. Storage security. AWS S3, public by default in the early years. Now private by default, but legacy buckets still cause breaches. Azure Blob Storage, private by default. Access keys often mismanaged. GCP Cloud Storage, private by default. IAM-based access reduces accidental exposure. 3. Network security, AWS VPC, highly customizable, but complexity equals misconfigurations. Azure VNet, integrated with enterprise networks. NSGs and ASGs provide layered control. GCP VPC, global VPC, firewall rules apply across regions unless scoped. 4. Encryption, AWS, encryption optional for many services. You must enable it. Azure, encryption enabled for most services. Customer managed keys optional. GCP, encryption at rest enabled by default for everything. Cloud providers learned a painful lesson early on. If they take responsibility for everything, they become responsible for every breach. So they drew a line, a very clear line, a line that says, we protect the infrastructure, you protect your data. This protects the provider, but more importantly, it forces customers to take security seriously. Section 12, the hidden layer, shared fate. In recent years, cloud providers introduced a new concept, shared fate. This means cloud providers now help you secure your part of the model, but they still don't own it. They guide you, but the responsibility is shared. Examples include AWS Control Tower, Azure Security Center, Defender for Cloud, GCP Security Command Center, Managed Detection and Response, Automated Compliance Checks, Misconfiguration Alerts, Identity Risk Scoring, and Policy Enforcement Engines. These tools help guide you towards securing your cloud environments. Shared fate is like having a personal trainer at the gym. They guide you, warn you about mistakes, and correct your form. But they can't list the weights for you. In the cloud, you must take responsibility for your own security actions and configuration. Section 13. The 90% problem. Misconfigurations. Here's a shocking fact. More than 90% of cloud breaches are caused by customer misconfigurations. Not by AWS, not by Azure, not by GCP, by customers. The cloud is secure. People are not. Examples of misconfigurations causing breaches include public S3 buckets, overpermissive IAM roles, open security groups, 0.0.0, exposed databases, hard-coded secrets, disabled logging, unrestricted API endpoints, misconfigured Kubernetes clusters, weak access keys, and lack of MFA. Section 14. Case Study. The Verizon Cloud Breach. A third-party contractor stored Verizon customer data in an unsecured S3 bucket. What went wrong? The bucket was public. No encryption, no access controls. It was the contractor who misconfigured the bucket, not AWS. Lesson: your weakest vendor becomes your biggest threat. Even if you use secure cloud platforms, a third party with poor security practices can lead to massive breaches. Every partner and vendor must be held to high standards in cloud security. Section 15. Case Study. The Facebook Cloud Breach. Millions of Facebook user records were exposed because a partner stored them in an open cloud storage bucket. What went wrong? Public access enabled, no monitoring, and no alerts were in place. Lesson: shared responsibility extends to your partners, vendors, and contractors. Even if your company has strong controls, others you trust with your data can create risks. Monitor and verify their security practices as part of your cloud security plan. Part 3. IAM Failures. Real attack paths, cloud security tools, and how hackers exploit shared responsibility. The screen fades into a dark digital landscape. A glowing lock appears in the center. Suddenly, the lock cracks and a single key falls out and hits the ground. In the cloud, attackers don't break in. They log in. The lock shatters. The camera zooms into a maze of cloud dashboards, IAM policies, and access keys floating like neon holograms, showing the complexity and vulnerability of cloud environments. Section 16. IAM, the most powerful, most dangerous part of cloud security. Identity and Access Management, IAM, is the beating heart of cloud security. It decides who can access, modify, delete, or create resources, escalate privileges, access sensitive data, or even shut down your cloud. If IAM is misconfigured, nothing else matters. A firewall won't save you, encryption won't save you, monitoring won't save you. That's because IAM is the master key controlling every action in your cloud. Its misconfigurations can override all other defenses. Section 17. The 5 most common IAM mistakes across AWS, Azure, GCP. These mistakes are responsible for thousands of breaches. Let's break them down with real-world clarity. Overpermissive roles. Just give admin access. This is the most common mistake in the world. A developer needs access to one S3 bucket, but instead of giving precise permissions, the admin gives administrator access. Why? Because it's easier. Because it avoids troubleshooting. Because we'll fix it later. Later never comes. Attackers love this mistake because one compromised account is total cloud takeover. One leaked key is full environment access. One phishing attack is complete disaster. This is how companies lose millions. Long-lived access keys. Developers often generate access keys and forget about them. These keys end up in GitHub repos, in Slack messages, in screenshots, in old laptops, in CI/CD logs, in browser extensions, in public forums, in Stack Overflow posts. Attackers scan the internet 24/7 for leaked keys. Once they find one, they don't guess your password. They don't brute force anything. They simply log in. Lack of MFA, multi-factor authentication. Without MFA, your cloud account is protected by one password, one phishing email, one reused credential, one brute force attempt, one leaked database. NFA is the seatbelt of cloud security. It doesn't prevent accidents, but it prevents death. Service accounts with too much power. Service accounts are used by applications, scripts, pipelines, containers, automation tools, but companies often give them full admin access. If an attacker compromises a service account, they bypass MFA, they bypass human monitoring, they bypass login alerts, they bypass behavioral analytics. Service accounts are silent, invisible, powerful, a perfect target. No IAM governance or review. IAM permissions grow like weeds. Every time someone asks for access, they get it. But nobody ever removes old permissions. This leads to privilege creep, dormant admin accounts, forgotten service accounts, orphaned identities, unused keys, excessive permissions. Attackers love old accounts. They're rarely monitored, rarely reviewed, rarely protected. Section 18. Real attack path. How hackers exploit IAM misconfigurations. Let's walk through a real-world attack path. This is exactly how attackers break into cloud environments. Step 1. Find a leaked access key. Attackers scan GitHub, GitLab, Bitbucket, Pastebin, public S3 buckets, Docker Hub, Stack Overflow, developer forums. They use automated tools like Trufflehog, GitLeaks, SheikGit, AWS Key Hunter, Google Dorking. Once they find a key, they test it. If it works, the attack begins. Step 2. Enumerate permissions. Attackers run commands like AWS IAM list roles, AWS S3 LS, AWS EC2 describe instances. They map out what the key can access, what permissions it has, what data it can read, what services it can modify. This is reconnaissance. If the key has weak permissions, attackers look for misconfigured IAM policies, roles that can be assumed, Lambda functions with admin access, EC2 instances with attached roles, over-permissive service accounts, and policies that allow privilege escalation. One common trick: if a role allows updating its own policy, attackers simply grant themselves admin access. Once attackers gain admin access, they copy S3 buckets, download databases, export secrets, access logs, steal customer data, extract intellectual property, and plant backdoors. This is the moment companies realize they've been breached. Attackers then delete logs, disable CloudTrail, modify IAM policies, create hidden admin accounts, plant persistence mechanisms, and encrypt data for ransom. By the time the company notices, it's too late. Modern cloud security is impossible without automation. Let's break down the essential tools. CSPM, Cloud Security Posture Management tools detect misconfigurations. Examples: Prisma Cloud, Wiz, Orca Security, Lacework, Checkpoint, Dome9, AWS Security Hub, Azure Defender, and GCP Security Command Center. They scan for public buckets, open ports, weak IAM policies, missing encryption, misconfigured firewalls, exposed databases, and non-compliant resources. CSDM is your cloud security camera system. CWPP, Cloud Workload Protection Platform Tools protect VMs, containers, Kubernetes clusters, serverless functions. Examples: Aqua Security, Sysdig, Trend Micro, Palo Alto Prisma, SentinelOne. They detect runtime attacks, malware, container escapes, privilege escalation, and lateral movement. CWPP is your cloud's bodyguard. CM, Cloud Infrastructure Entitlement Management Tools focus on IAM. Examples: Emetic, Sunrise Security, SailPoint, CyberArk, Beyond Trust. They detect over-permissive roles, privilege creep, dormant accounts, excessive service accounts, and risky permissions. CIEM is your cloud's identity auditor. SIEM, Security Information and Event Management Tools collect logs and detect threats. Examples: Splunk, Microsoft Sentinel, Elastic SIEM, IBM QRadar, Chronicle Security, GCP. SIEM is your cloud's detective. Attackers know one thing. Most companies don't understand what they're responsible for. So they exploit misconfigured S3 buckets, open security groups, weak IAM roles, exposed databases, and unsecured APIs. They also exploit lack of monitoring, no MFA, hard-coded secrets, public GitHub repos, and overprivileged service accounts. Attackers don't need to break AWS, they just need to break you. Section 21, Case Study, Tesla Kubernetes Breach. A Kubernetes console was left exposed. Attackers gained access and used Tesla's cloud resources to mine cryptocurrency. What went wrong? No authentication, no network restrictions, no monitoring, no IAM controls. Lesson: cloud resources can be abused even without stealing data. Section 22, Case Study, Uber AWS Breach. A contractor's access key was leaked. Attackers used it to access Uber's cloud environment. What went wrong? 4. Hard-coded secrets, no key rotation, over-permissive IAM, no MFA, no monitoring. Lesson: one leaked key can compromise an entire company. Art 4. Building a secure cloud foundation. Best practices, actionable checklists, and the cinematic conclusion. The screen opens with a wide aerial shot of a futuristic digital city. Glowing networks, floating data streams, and cloud platforms rising like skyscrapers. The camera slowly zooms into a single building under construction. Narrator, calm, confident. Every secure cloud environment begins the same way, with a strong foundation. Because in the cloud, you don't rise to the level of your ambition. You fall to the level of your configuration. The building's foundation glows brighter as layers of security stack on top of each other. Section 23, the Secure Cloud Foundation, a step-by-step blueprint. Most companies rush into the cloud. They deploy workloads before they deploy security. They build applications before they build governance. They create users before they create policies. This is why breaches happen. A secure cloud environment must be built like a skyscraper, from the ground up, layer by layer, with intention and discipline. Let's break down the blueprint. Step 1. Identity first. Build IAM before you build anything else. Identity is the perimeter in the cloud. There are no physical firewalls, no locked server rooms, no guards. Your IAM is the front door, the back door, the windows, and the roof. What to do? Enforce MFA for every user. Use SSO and federated identity. Use roles instead of long-lived access keys. Apply least privilege everywhere. Review permissions monthly. Remove dormant accounts. Rotate keys automatically. Use conditional access policies. Use identity protection tools. Azure AD Identity Protection, AWS IAM Access Analyzer, GCP IAM Recommender. Analogy: IAM is like issuing ID cards in a corporate office. You don't give every employee a master key. You give them access only to the rooms they need. Step 2. Network segmentation. Build walls inside the cloud. A flat network is a hacker's playground. If attackers get into one resource, they can move laterally to everything else. What to do? Create separate VPCs, VNets for dev, test, prod. Use subnets for segmentation. Use security groups and NSGs to restrict traffic. Deny all inbound traffic by default. Use private endpoints for cloud services. Use VPC service control to provide boundary protection. Use Transit Gateway or Azure Virtual WAN for controlled routing. Block 0.0.0.0/0 unless absolutely necessary. Use WAFs for public applications to prevent exposure to threats on the internet. Analogy: a hotel doesn't give guests access to every room. Each room is isolated. Each floor has restricted access. The cloud must work the same way. Step 3. Encryption everywhere. Protect data at rest, in transit, and in use. Data is the crown jewel. Attackers don't break into cloud environments for fun. They break in for data. What to do? Enable encryption at rest for all storage. Use customer-managed keys, CMK, for sensitive data. Rotate keys automatically. Use TLS 1.2+ for all traffic. Use HSMs for high-security workloads. Use envelope encryption for layered protection. Use confidential computing for sensitive workloads. Azure, GCP. Analogy: even if someone breaks into your house, they shouldn't be able to open your safe. Step 4. Logging and monitoring. Visibility is everything. You cannot protect what you cannot see. Most breaches go undetected for months because companies don't enable logging. What to do? Enable CloudTrail, AWS. Enable activity logs, Azure. Enable cloud audit logs, GCP. Send logs to a SIEM, Sentinel, Splunk, Chronicle. Enable guard duty, Security Center, or SCC. Monitor IAM activity. Monitor network flows. Monitor API calls. Set alerts for privilege escalation. Set alerts for public bucket creation. Set alerts for failed login attempts. Analogy: a bank without security cameras is inviting criminals to walk in. Step 5. Secrets management. Never store secrets in code. Hard-coded secrets are one of the biggest cloud security failures. What to do? Use an AWS Secrets Manager. Use Azure Key Vault. Use GCP Secret Manager. Rotate secrets automatically. Remove secrets from code, GitHub, CI/CD. Use environment variables securely. Use IAM roles instead of keys whenever possible. Analogy: leaving your house key under the doormat is convenient, but it's also the first place attackers look. Step 6. Secure CI/CD pipelines, the new attack surface. Modern attacks target pipelines, not servers. What to do? Use least privilege for pipeline service accounts. Scan code for secrets. Scan containers for vulnerabilities. Sign container images. Use private registries. Restrict pipeline access to production. Use DevSecOps tools, SNCC, Aqua, checkmarks. Enforce security gates before deployment. Analogy: if your supply chain is compromised, your entire product is compromised. Governance is not about slowing teams down. It's about preventing disasters. What to do? Use AWS organizations, Azure management groups, GCP organizations. Apply SCPs, Azure policies, GCP organization policies. Enforce tagging standards. Enforce encryption policies. Enforce network restrictions. Enforce IAM boundaries. Use automated compliance checks. Use CIS benchmarks. Use NIST, ISO, SOC 2 frameworks. Analogy: Guardrails on a highway don't stop you from driving fast. They stop you from driving off a cliff. This checklist is designed for companies, learners, and cloud architects. Identity and access, MFA enabled for all users. No long-lived access keys. Least privilege enforced. IAM roles used instead of users. Service accounts restricted. Permissions reviewed monthly. SSO enabled. Conditional access policies applied. Network security. No public access unless required. Private endpoints enabled. Segmented VPCs or VNets. WAF enabled for public apps. No 0.0.0.0 inbound rules. Firewall rules reviewed regularly. Data protection. Encryption at rest enabled. Encryption in transit enforced. CMKs used for sensitive data. Key rotation automated. Backups encrypted. Data classification applied. Monitoring and detection. Logging enabled for all services. Logs sent to SIEM. Alerts configured for critical events. Threat detection enabled. IAM activity monitored. Network flows monitored. Secrets management. No secrets in code. Secrets manager or key vault used. Automatic rotation enabled. Access restricted by IAM. Application workload security. Containers scanned. Images signed. Vulnerabilities patched. Serverless permissions restricted. Runtime protection enabled. Governance and compliance. Policies enforced. CIS benchmarks applied. Automated compliance checks. Resource tagging enforced. Cost governance applied. Imagine a massive castle. AWS, Azure, and GCP built the castle walls. They built the towers. They built the gates. They built the drawbridge. They built the moat. But inside the castle, that's your kingdom. You decide who gets a key, which rooms are locked, and where the treasure is stored. You also decide whether the guards are awake, whether the windows are open, whether the torches are lit, and whether the alarms are working. If you leave the treasure room unlocked, the castle builders are not responsible. This is the shared responsibility model. The screen fades to black. Soft music begins. Cloud security is not a tool. It's not a service. It's not a checkbox. It's a mindset. The screen shows a developer writing secure code, a security engineer reviewing IAM, a cloud architect designing networks, a company enabling NFA, a team responding to alerts, a secure cloud environment glowing like a fortress. The cloud gives you power, but power without discipline becomes chaos. The shared responsibility model is not a burden. It's a partnership, a promise, a blueprint for resilience. The music rises. AWS protects the infrastructure. Azure protects the platform. GCP protects the backbone. But only you can protect your data. The Knowitrix logo appears. Section 27, the final call to action. If you want to master cloud security, if you want to build systems that never fail, if you want to become the architect companies trust, then keep learning, keep growing, and stay with us. This is Knowitrix, where the future of cybersecurity begins.